Machine learning has gone through many recent developments and is becoming more popular day by day. People from all domains, including computer science, mathematics, and management, are using machine learning in various projects to find hidden information in data. It was just a matter of time that Spark jumped into the game of machine learning with Python. So guys, this is Kisle from Edureka, and the topic for today's discussion is the PySpark MLlib. So let's have a quick look at today's agenda. I'll start off this video by giving you a brief introduction to machine learning with its various implementations in the industry. Next, I'll discuss the three major domains of machine learning, which are supervised, unsupervised, and the reinforcement learning. Next, I'll discuss how MLlib plays an important role in the Spark environment, and finish off this video with a demo on PySpark MLlib. So let's begin. Now, what exactly is machine learning? Machine learning is a method of data analysis that automates analytical model building. Using algorithms that iteratively learn from data, machine learning allows computers to find hidden insights without being explicitly programmed where to look. It focuses on the development of computer programs that can teach themselves to grow and change when exposed to new data. Machine learning uses the data to detect patterns in the dataset and adjust programs' actions accordingly. Most industries working with large amounts of data have recognized the value of machine learning technology. By gleaning insights from this data, often in real time, organizations are able to work more efficiently or gain an advantage over competitors. Now let's have a look at the various industries where machine learning is being used. Government agencies such as public safety and utilities have a particular need for machine learning. They use it for face detection, security, and fraud detection. Now marketing and sales. Now websites recommending items you might like based on previous purchase use machine learning. They use it to analyze your buying history and promote other items you'd be interested in. Now, analyzing data to identify patterns and trends is the key to the transportation industry, which relies on making routes more efficient and predicting potential problems to increase the profitability. Now, coming to the financial service, banks and other business in the financial industry use machine learning technology for two key purposes. The first one is to identify important insights in data, and the second one is to prevent fraud. Now, coming to healthcare. Machine learning is a fast-growing trend in the healthcare industry, thanks to the advent of wearable devices and the sensors that can use data to access a patient's health in the real time. Now, finally, in the biometrics section, the science of establishing the identity of an individual based on the physical, chemical, or the behavior attributes of the person is one of the major key advantages of machine learning in the biometrics area. Now, let's have a look at a typical machine learning lifecycle. Any machine learning lifecycle is divided in two phases. The first one is training and the second one is testing. Now for training we use the 70 to 80% of the data and the remaining data is used for testing purposes. So first of all we train the data and we use any particular algorithm to train the data, and using that algorithm we produce a model. Now after that we have produced our model, now the remaining 20 to 30% of the data is used for the testing purposes. We pass this data to the model and we find out the accuracy of that model with certain tests. Now this is what a typical machine learning lifecycle looks like. Now there are three major categories of machine learning, as I mentioned earlier, which are supervised, reinforcement, and the unsupervised learning. So let's understand these terms in detail, starting from supervised learning. Now supervised learning algorithms are trained using labeled examples, such as input where the desired output is known. The learning algorithm receives a set of inputs along with the corresponding correct outputs, and the algorithm learns by comparing its actual output with the correct output to find errors. It then modifies the model accordingly through methods like classification, regression, predicting, and gradient boosting. Supervised learning uses patterns to predict the values of each label on additional unlabeled data. It is called supervised learning because the process of an algorithm learning from the training data set can be thought of as a teacher supervising the learning process. Now, supervised learning is majorly divided into two categories, namely classifications and regression algorithms. Regression is the problem of estimating or predicting a continuous quantity. What will be the value of the S&P 500 1 month from today? How tall will a child be as an adult? How many of the customers will leave for a competitor this year? These are examples of the questions that would fall under the umbrella of regression. Now coming to classification. Classification deals with assigning observation into discrete categories rather than estimating continuous quantities. In the simplest case, there are two possible categories. This case is known as binary classification. Many important questions can be framed in the terms of binary classification. Will a given customer leave us for a competitor? Does a given patient have cancer? Does a given image contain a dog or not? Now, classification mainly consists of classification trees, support vector machines, and random forest algorithms, whereas regression consists of linear regressions, decision trees, Bayesian networks, and fuzzy classification. Now, there are other algorithms like artificial neural network programming and gradient boosting, which also comes under supervised learning algorithms. Now, next we have reinforcement learning. Now, reinforcement learning is learning how to map situations to actions so as to maximize a reward, and often used for robotics, gaming, and navigation. With reinforcement learning, the algorithm discovers through trial and error which actions yield the greatest rewards, and the algorithm provides information about whether the answer is correct or not, but does not tell how to improve it. The agent is the learner or decision maker, whose job is to choose actions that maximize the expected reward over a given amount of time. Actions are what the agent can do, and the environment is everything the agent interacts with. The algorithm, whose ultimate goal is to acquire as much as numerical reward as possible, gets penalized each time its opponent scores a point, and gets rewarded each time it manages to score a point against the opponent. It uses this feedback to update its policy, and gradually it filters out all the actions that lead to penalty. Reinforcement learning is useful in cases where the solution space is enormous or infinite, and typically applies in cases where the machine learning can be thought of as an agent interacting with its environment. Now, there are many reinforcement learning algorithms. Few of them are the Q-learning. We have the SARSA, which is the state action reward state action. We have deep Q network. We have the deep deterministic policy gradient, which is DDPG. And finally, we have the TRPO, which is the trust region policy optimization. Now, the last category of machine learning is unsupervised learning. So as I mentioned earlier, supervised learning tasks find patterns where we have a data set of the right answers to learn from. Whereas in case of unsupervised learning, tasks find patterns where we do not. This may be because the right answers are unsolvable or infeasible to obtain, or maybe for a given problem there isn't even a right answer per se. A large subclass of unsupervised tasks is the problem of clustering. Clustering refers to grouping observation together in such a way that members of a common group are similar to each other and different from members of other groups. A common application here is in marketing, where we wish to identify segments of customers or prospects with similar preferences or buying habits. A major challenge in clustering is that it is often difficult or impossible to know how many clusters should exist or how the cluster should look. Unsupervised learning is used against data that has no historical labels. The system is not told the right answer. The algorithm must figure out what's being shown. The goal is to explore the data and find some structure within. Unsupervised learning works well on transactional data, and these algorithms are also used to segment text topics, recommend items, and identify data outliners. Now, there are majorly two classifications of unsupervised learning. One is clustering, as I discussed earlier, and the other one is dimensionality reduction, which includes topics like principal component analysis, tensor decomposition, multidimensional statistics, and random projection. So now that we have understood what is machine learning and what are its various types of machine learning, let's have a look at the various components of Spark ecosystem and understand how machine learning plays an important role here. Now, as you can see here, we have a component named MLlib. Now, PySpark MLlib is a machine learning library. It is the wrapper over the PySpark core to do analysis using machine learning algorithms. It works on distributed systems and is scalable, and we can find implementation of classification, clustering, linear regression, and other machine learning algorithms in PySpark MLlib. We know that PySpark is good for iterative algorithms. Using iterative algorithms, many machine learning algorithms have been implemented in PySpark MLlib. Apart from PySpark's efficiency and scalability, PySpark MLlib APIs are very user-friendly. Software libraries, which are defined to provide solutions for the various problems, come with their own data structure. These data structures are provided to solve a specific set of problems with efficient options. PySpark MLlib comes with many data structures including dense vectors, sparse vectors, and a local and distributed matrix. So the major MLlib algorithms include MLlib, we have clustering, we have frequent pattern matching, we have linear algebra, we have collaborative filtering, we have classification, and finally we have linear regression. Now let's see how we can leverage MLlib to solve our few problems. So let me explain this use case to you. A system was hacked, but the metadata of each session that the hackers used to connect their servers were found. Now these included features like session connect time, the bytes transfer, we have the Kali trace used, we have certain data like servers corrupted, pages corrupted, the location, and we have the WPM typing speed. Now there are three potential hackers, two confirmed hackers and one not yet confirmed. The forensic engineers know that the hacker trades off attacks, meaning they should each have roughly the same amount of attacks. For example, if there were 100 attacks, then in a two hacker situation, each would have 50 attacks, and in a three hacker situation, each would have 33 attacks. So here we are going to use clustering. So let's see how we can use clustering to find out how many hackers were involved. So today I'm going to use the Jupyter notebook to do all my programming. Let me just open a new Python 2 Jupyter notebook. So first of all, what we are going to do is import all the required libraries and initiate the Spark session. Now next what we are going to do is read the data using the spark.read method. Now here we are doing spark.read.csv as our dataset is in CSV format and we have given header and info schema as true. Now here the default location what it takes is HDFS when we do the spark.read. So in order to change the default location to your local file system, you need to provide file colon and 2 forward slashes and then provide the absolute part of the data file which we are going to read. Now let's have a look at the first record of the data frame and also the summary of the data set. Now to have a summary of the data set, we use the describe function here. Now the output of this one is very haphazard, so if we want to have a look at the names of the columns which we have here, we just need to use the dataset.columns. So as you can see, we have the session connect time, we have the bytes transferred, we have Kali trace used, servers corrupted, pages corrupted, the location, and the WPM typing speed. Now WPM stands for words per minute. Now next what we are going to do is import the vectors and the vector assembler library. Now these are all machine learning libraries which we are going to use. Now what vector assembler does is take a set of columns and define a particular feature. So our features consist of the session time, the bytes transfer, the Kali trace used, we have the servers corrupted, the pages corrupted, and the WPM typing speed. One thing to note down is that the feature selection is based on us. So whatever be the feature selection, if our model is not predicting the right output, we can change the features accordingly to get the desired output. Now I've created a VEC underscore assembler which will take all the above defined attributes, and based on that it will provide us the feature column. Now what next we are going to do is make our final data, and we'll use vector assembler and transform it on the dataset which we have. Now next what we'll do is we'll import the standard scaler library. Now centering and scaling happen independently on each feature by computing the relevant statistics on the samples in the training set. Mean and standard deviation are then sorted to be used on the later data using the transform method. Standardization of the dataset is a common requirement for many machine learning estimators. They might behave badly if the individual feature do not more or less look like standard normally distributed data. Now let's compute the summary statistics by fitting the standard scaler. And then let's normalize each feature to have a unit standard deviation. Now finally we have the cluster final data. It's time for us to find out whether there were 2 or 3 hackers. So for that we are going to use k-means here. So I've created k-means 3 and k-means 2. K-means 3 will have all the features with the k value as 3, and the k-means 2 will have the features column which are the scaled features with the k value as 2. Now what we'll do is create models for these both k-means 3 and k-means 2 variables. We are going to fit it into the cluster final data. Now WSSE stands for within set sum of squared errors. So let's have a look at the values of these for the model which has k equals 3, that is 3 clusters, and for the model which has k equals 2. Now for k equals 3, the set sum of squared errors is 434, and for k equals 2, it is 601. Now let's have a look at the values of k starting from 2 to 9 to have a look at the values of within set sum of squared errors. As you can see, the values are getting lower and lower. That means the probability of the number of hackers being more than 3 and 4 is very less. As you can see, for k equals 8 is 198. Now the last key fact the engineer mentioned was that the attacks should be evenly numbered between the hackers. Let's check with the transformation and prediction column that the result for this. Now grouping by prediction, we'll see, as you can see, if we have the prediction of 3 hackers, the count is 167, 79, and 88, which is not evenly distributed. So if we have a look at the data for k equals 2 with the model k2 and do the prediction, so guys, as you can see here, the count is evenly distributed. This means that only 2 hackers were involved. The clustering algorithm created 2 equal side clusters with k equals 2 and the count being 167 for each one of them. So this is one way through which we can find out how many hackers were involved using k-means clustering. So let's move forward with our second use case, which is the customer churn prediction. Now, customer churn prediction is big business. It minimizes customer deflection by predicting which customers are likely to cancel a subscription to a service. Though originally used within the telecommunication industry, it has become common practice across banks, ISPs, insurance firms, and the other verticals. The prediction process is heavily data-driven and often utilizes advanced machine learning techniques. In this post, we'll take a look at what type of customer data are typically used to do some preliminary analysis of the data and generate churn prediction models, all with PySpark and its machine learning framework. So let's have a look at the story of this use case. Now, a marketing agency has many customers that use their service to produce ads for the client and customers. They've noticed that they have quite a few bit of churns in the clients. They basically randomly assign account managers right now, but they want you to create a machine learning model that will help predict which customers will churn so that they can correctly assign the customers most at risk to churn an account manager. Luckily, they have some historical data. So can you help them out? Do not worry, I'll show you how to help them. So we need to create a classification algorithm here that will help classify whether or not a customer churned. Then the company can test this against the incoming data for future customers to predict which customers will churn and assign them an account manager. So let's import the libraries first which we need. So here we are going to use Logistic Regression to solve this method. Now the data is saved as customer_churn.csv. So we'll use the spark.read method here to read the historic data, and then we'll have a look at the schema of the data and understand what exactly are we dealing with. Now to understand the schema of any particular data frame or the data, we use the print schema method. So as you can see here guys, we have name, age, we have the total purchase, we have account manager, years, the number of sites, onboard date, location, company, and the churn. So let's have a look at the data. So as you can see here, we have data of 900 customers here. So I've used the count method to get exactly the number of rows to see how much we are dealing with. Now let's load up the test data as well and now have a look at the schema of this data. So as you can see, the test data is also in the same format as the training data. Next, what we are going to do is import the vector assembler library. Now since I've already imported the vector assembler library here, as you can see earlier in this, we have done from PySpark.ml.feature import vector assembler. So I'm not going to import it again as it will show us some error. Now firstly, we must transform our data using the vector assembler function to get to a single column where each row of the data frame contains a feature vector. Now this is a requirement for the regression API in MLlib. So as you can see here, I'm using age, the total purchase, the account manager, the years, and the number of sites. I must say it's dependent on the user that is creating the model. So say that this model is not giving us the output as we want or we require, so we'll change the parameters of the input columns. Now here what we are doing, we are creating an output underscore data, which is a data frame which will contain the data of the input data which has been converted using all these input columns or the features, and have a single output of the column named features. So let's have a look at the schema of this new output data. So guys, as you can see here, all the columns are the same except the last one. In the last, we have an additional feature column and it's a vector. So this will help us in the prediction of the customer churn. Now in order to have a look at what we are dealing here, let's take a look at the output of the first element. So as you can see here in the last, we have the features, which is a dense vector containing all the 5 values of the column, which is 42, age, 1166, which is the total purchase. We have 0.0, which is account manager. We have 7.2 years, and we have the number of sites, which is 8. So now what we are going to do is create our final data we'll use this output data which we have from the vector assembler, and what we'll do is only select the features and the churn. So if we have a look at the final data, so as you can see here, we have only two columns, which are the features and the churn. So now what we are going to do is split our data into training and testing data. For now, we are going to use the random split method, and we are dividing it in the ratio of 70:30. Now what we are going to do is create our logistic regression model. And now we are going to use the column churn for the label. So now let's train the model using our training data, which we just now created from our final data. So let's have a look at the summary of the model which we just created. So guys, as you can see here, we have the churn, the prediction, we have the mean, standard deviation, the minimum and the maximum value. Now that we have created our model, let's use it to get the value of the evaluator on the raw prediction data. Now for that, we need to first import the binary classification evaluator. We are creating a data frame predictions in which we'll fit the test data into the model and evaluate using the binary classification evaluator. Now when we have a look at the output data, we can see on the left hand side we have the features, then we have the churn, then we have the raw prediction according to our model, then we have the probability, and finally the prediction. So let's use the evaluator, which has the binary classification evaluator. It will take the prediction column and the label column churn and tell us how accurate is our model. So as you can see, it's 77% accurate. So earlier I loaded the test data. I'll show you. Here you can see we have the new customers.csv. So we used the original data, split it into 70:30 ratio. Then we created a model and trained it using our training data, and then tested it using the testing data. So now we'll use the incoming new data, which is the new customers, and see if our model is fit or not. Now again, we are going to use the assembler, the vector assembler here. Now we have created a data frame results in which it will take the logistic regression model and transform it using the new test data. And this new test data also contains the features column because we used the vector assembler just before that. So if we have a look at the results, it's very haphazard here. I'll show you another format. Just hang on a second. So what we are going to do is select the company and the predictions just to see how it's working. So as you can see, the Cannon Benson prediction is true. Barron Robertson prediction is true. The Sexton Golden is also true, and the Park Robinson also. So guys, as you can see, our model was 77% accurate. Now we can play along with the features column to see if our model produces a more accurate output. So in our case, if we are satisfied with the 77% ratio of the model being true, the prediction being true, then it's fine. But then again, we can change it according to our preferences. So guys, this is it for PySpark MLlib. I hope you understood a lot about the PySpark, how machine learning works in the industry, where it is being used. We have the supervised, unsupervised reinforcement learning, and I hope you got how to do programming using the MLlib library of Spark. Thank you so much.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!